Yes, student, after the study of the phenol, that is the introduction of phenol, its electronic structure, then classification of phenol, then different type of compounds and their names. Now we entered in the next content. This is method of preparation of phenols. Okay, this is benzene ring and OH. So student, the first method is from benzene diazonium chloride salt. Okay, now what is benzene diazonium chloride? In the first chapter of organic chemistry, we have seen one of the reaction, that was Sandmeyer reaction, through which we learned how to prepare chlorobenzene. In that reaction, we have checked diazotization process. Okay, what is the diazotization process? That is the preparation of benzene diazonium chloride salt. Okay, diazotization is the process of preparation, okay, of diazonium chloride. And how do we prepare it? Using what? You know, aniline, okay, HCl, okay, and sodium nitrite, okay, at 0 degrees Celsius to 5 degrees Celsius temperature. Isn't it? That means in the ice cold atmosphere. So from this process, first we have to prepare what? Benzene diazonium chloride salt. Then the salt, that is benzene diazonium chloride salt, the salt is warmed with water, okay, which gives what? Phenol. So student, the first step I am not writing because it is already mentioned. I am directly writing the second step, that is warming up of benzene diazonium chloride salt with water to form phenol. Now what is benzene diazonium chloride salt? This is benzene, then nitrogen, one more nitrogen, and then Cl. This is called benzene diazonium chloride salt. When this salt is warmed with water, that is hydrolysis, you can say hydrolysis or warmed with water. Here the benzene diazonium chloride salt converts into what? Phenol. This is phenol plus here N and N, that is nitrogen gas is releases along with here H and Cl forms HCl. Okay, so this is the first method. Second method, from salicylic acids, okay, salt. That is, we have not to use salicylic acid, besides of it we have to use its salt. Now what is salicylic acid? Ortho, okay, hydroxy benzoic acid, Okay, this is called what? Salicylic acid. It's sodium salt, okay, when, okay, heated with soda lime. Now what is soda lime? Okay, that is sodium hydroxide and quicklime. This is the mixture of sodium hydroxide and quicklime, like NaOH plus what? CaO. This is called quicklime. Okay, and then, okay, reacted with hydrochloric acid, that is HCl. Now how it is? So you can write reaction. This is COO, and I told you what? It's a sodium salt means Na, and this is OH. So this is called orthohydroxy, okay, salicylic acid, and it's a sodium salt. So sodium salt of salicylic acid. You can call it sodium salt of salicylic acid. When this is reacted with soda lime. Now what is soda lime? So this is NaOH and CaO, that is quicklime. So when the reaction takes place, first what? The OH, the H is releases from here and it form O, Na, and now this Na2, Na and Na2, and with O become Na2CO3. So this is minus Na2CO3. When it reacted in the next step with what? HCl. Now Na and Cl become what? NaCl, and the remaining part H will enter here. So this will become what? Phenol. This will become phenol. This is O and this one is what? H. Okay. So this is the second method of preparation. Okay. Third method is from, now this is name reaction. This is called Dawes process. Okay. This is called what? Industrial preparation. What is this? Industrial preparation. Student, you have also checked this reaction in previous chapter. What? The nucleophilic substitution reaction of chlorobenzene, where the chlorobenzene is heated with sodium hydroxide, but at high temperature and high pressure. Isn't it? So the same reaction here we have to write. What? When the chlorobenzene, this compound is what? Chlorobenzene, okay, Cl, chlorobenzene, when heated with sodium hydroxide, NaOH, and the temperature and pressure condition 623 Kelvin temperature and 200 to 300, okay, what? Pressure. Here the nucleophilic substitution reaction takes place, means the OH enters here and Cl react with Na. Okay, so forming what? Phenol. This is phenol plus NaCl. Student, this reaction is already checked in very described form, and we have also checked one of the very important CBSE question. What? Why do haloarine do not easily gives nucleophilic substitution reaction? Okay, so the long discussion, the comprehensive discussion is already done on that topic. Fourth one is from cumene. This is called what? Commercial preparation of phenol. Commercial preparation of phenol. Commercial method. That is at very large scale. If we have to prepare, then we are using this reaction. But very first we have to find what is cumene. Okay, cumene is first obtained using benzene and propene. Benzene and propene, that is what? Alkene. It is unsaturated. Okay, at 525 Kelvin in the presence of H3PO4. H3PO4. Then cumene is reacted with excess of oxygen, and then, that is, when it is reacted with excess of oxygen, then it is hydrolyzed using what? Acid. It forms what? Phenol. So student, you can write the reaction as so first we have to prepare what? Cumene. Okay, and what is cumene? The reaction of benzene, this is what? Benzene with propene, CH3 CH2. Okay, and the reaction condition is what? 525 Kelvin temperature in the presence of H3PO4, that is phosphoric acid. So it forms first cumene compound. What is the cumene? It is very interesting compound. CH3, and this is CH3. Okay, and this is what? H. This compound is called what? Cumene. Okay, chemically, what is the cumene? It is what? Isopropyl benzene. Now, why I am calling it isopropyl benzene? You can see here 1, 2, 3. That is 3 carbon having alkyl radical. But the second carbon is attached directly with carbon of benzene ring. Therefore, the term used what? Iso. If it attached with the first carbon, then it will simply propyl benzene. But remember, it is attached with what? Which number carbon? Second number carbon atom of what? Benzene. Okay. There of what? Alkyl. Therefore, it is called what? Isopropyl. Now, in the next step, this isopropyl, this compound is called what? Cumene. Okay. Now, the cumene in the next step means this one, C. This is CH3 and this is CH3. So, when it reacted with excess of O2, that is oxygen gas is bubbled with it, then what? The oxygen is directly attached to it, forming peroxide. This compound, okay, this is C, this is one more CH3, this is CH3, and now the CH bond is ruptured and the oxygen entered here, forming O, and now this is what? H. This is called peroxide. But you know, the peroxide compounds are highly unstable. So when the compound is heated, okay, then it, that is hydrolysis, it converts into phenol, that is OH, plus one more compound CH3, C, double bond O and CH3. That means here the two very important compounds obtained. First one is phenol and what? Second one is acetone. So the two compounds are simultaneously obtained by this reaction. Therefore, this reaction is very, very important reaction. Okay, you do write here what? Hydrolysis. H2O in presence of H cation. Getting? So in this way, the method of preparation completed. You can check some more method of preparation from NCERT book and also use at least one reference book. Yes, student, now the next content is physical properties of phenols. So first one about state. Okay. Phenols in pure state are colorless liquid or crystalline solid. Okay, depending on temperature, crystalline solid. Okay, but when exposed to atmosphere becomes pink or red brown in color. Therefore, student, the phenols are stored under brown color thick wall glassware. Okay, so that its property remains same. Okay, second one is solubility. Phenols are soluble in water. We are using at our home, isn't it? In mopping of floors, etc. It is known as insecticides, pesticides, and we are frequently using it. Phenols are soluble in water, but its solubility is lesser than alcohol. Now, alcohol are what? It is having what? ROH group. But in phenol, there is what? Benzene ring. Okay. Due to presence of benzene ring, okay, solubility decreases. Okay. However, presence of polar nature of OH group. Okay. Phenols are able to form hydrogen bond, okay, with water molecule. Now how it is? So you know that in phenol there is O and there is what? H. This is, so it is fraction negative, this is fraction positive. So this is what? Polar in nature. When it is dissolved in water, now the water is also what? Polar in nature. Fraction negative and fraction positive. So now it forms new intermolecular attraction force. This is called what? Hydrogen bonding. Even between phenols and phenols there is hydrogen bonding, and water hydrogen bonding. So if these two are mixed together, again the hydrogen bond form, which is just similar to previous hydrogen bond, although its magnitude is little lesser. Therefore what? It is soluble, but what? Sparingly soluble. We can say sparingly soluble in water. Okay. And now third one, boiling point. boiling point. Boiling point of phenols. Okay, we have to do, it's a comparative study. Okay, boiling point of phenol is 455 Kelvin. Okay, quite high, even more than what? Water. Okay, water boiling point is 373 Kelvin. But in phenol, there is benzene ring, the molecular mass increases, therefore van der Waals attraction force magnitude also increases. Therefore, its boiling point increases. But the boiling point of phenol is 455 Kelvin. It is very high, but is even higher than corresponding what? Arenes. Now, what is the corresponding arenes by which it is derived? This is what? Benzene. So, its boiling point is higher as compared to benzene. Now, why? It is because in benzene, there is only dispersion force. So, in arenes what? There is only dispersion force. Dispersion. And the dispersion force is what? Weak in nature. Okay. And in phenol, what? Hydrogen bond is present. Hydrogen bond is present. Okay. Therefore, due to presence of hydrogen bond, its boiling point is higher. Even the boiling point of toluene. Now, what is toluene? Toluene what? Benzene ring with CH3. Now, what is the molecular mass of toluene? This is 92 Kelvin. Okay. Even the boiling point of toluene is lesser than phenol. Now, the same reason. What is the same reason? In case of toluene, again, only dispersion force is present. But in case of phenol, the strong intermolecular hydrogen bonding is present. And you know that the intermolecular hydrogen bonding magnitude is very, very high. Student, actually the molecular mass of phenol is what? 94 Kelvin. And the toluene is what? 92 Kelvin. So, from the point of view van der Waals attraction, the attraction force is same in case of toluene and phenol. But now the boiling point will be decided by the nature of two compounds, that is toluene and phenol. Getting? Phenol is having polarity, but the toluene is a non-polar compound. And you know that the non-polar compound belongs only dispersion force, while the polar molecule belongs what? Polarity. That is, phenol belongs to polarity. Student, here we can discuss some more boiling point of different type of compounds. Okay, like what about the chlorobenzene? So one which will have greater polarity will have higher boiling point. But remember, here we have to compare the boiling point of two compounds if their molecular masses are same. If the molecular mass will change, then the boiling point will also getting what? Change.